directly?
Yeah, you can go straight into it.
Okay, good evening and thank you for having me here. And I want to talk about this evening about digital transition from analog X-rays in NDT to digital. And I will address this in about 20 minutes speech and provide options for your questions later on. And afterwards, Sean is going to present a little bit more about CR opportunities. And then I believe we have some hands-on training or presentation if requested.
If anybody would like to see some digital images that I do have there, and then annotations and viewing going forward and that. So.
If of any interest, also just to warn you, we are on tape. We will be providing this presentation, if requested, to Sean on edited version, just the content, if you're interested in this, just for information. Just a little bit introduction. There are many names. This solution you are about to see tonight is manufactured in Germany using an American-made scanner. And in Germany, we are enhancing our solution with special technology, upgrades for NDT, special solutions for adapting to NDT needs, like small film strips. And we are going to provide you today with a presentation, not a product presentation, but actually an overview of how we think that the age of digital comes to the NDT from going from analog film to the digital world. Currently, you probably all have seen the opportunity back 20 years ago where there was a transition over from on digital photography from the good old cameras with 35mm films all to digital photography today. We have seen similar arrangements in the medical market, and currently we are going from, when you go back to the good old film, whether it's 35mm or analog X-rays, medical have done the transition over over the past 15 to 20 years, and mostly you are in the medical field today filmless. And in the NDT, we are seeing in exactly the same transitions, just about 15 years later, and of course super specialized on NDT quality requirements, and also on, of course, very special software which meets the needs of the NDT market. One of the biggest topics we have encountered over the past 2 years since we started this, that many of you are probably already working with digital systems, whether it's a CR or a DR system, and somehow it was forgotten that there is also billions of X-rays which are in the good old file vaults, which can be transferred in order to be compatible with the new digital technology. And we are basically providing, very easy to say, we have a bridge to be able to come from analog to digital. What is digital radiography? I don't want to lecture on you on this. I'm sure that you all know about digital radiography, and it's basically, we just added up here what this is all about. I'm not going to make any big presentations on this topic unless you have specific questions. What do you need to be prepared for digital? You need to know, of course, the digital fundamentals about digital imaging. Worldwide, we have standards to follow. And on our international market, and please, Sean, if there's a special certification for the South African market, if you could please also mention these. Yeah. So the ASTM standards, the solution we are showing you today is completely compatible and on certification to the BAM standards from Berlin, the Bundesanstalt für Materialforschung, and also from the ASNT and ASMT from the United States, that we are following exactly those guidelines on optical densities, on resolutions, on how a film must look like to be valid for digital imaging in NDT. There is, for the ASNT in the United States, they have courses in digital imaging, qualifications in digital imaging. This is, of course, good to have one of those courses. We have digital systems performing baselines. That means there is a certain requirements on hardware, software, on monitors, how to display this. But this is you can use standard technology. So any normal, like we have here, a normal notebook can be used for presentation, as well as highly specialized monitors for much higher display quality. We have image quality measures, which needs to be transferred. We have, of course, the user must be computer literate in order to really use that technology. And we also have created a totally new interface on software from the analog to the digital world. What's so great about digital? And I'm sorry if this is really basic, but it's good to just focus there and then you see where I'm going with this. When you have digital images, you can adjust brightness, adjust contrast. And I've seen really that good old level 3s and experienced NDT users were surprised to see how easy you can play around once you have a X-ray digitized, what you can get out of those images by simply changing contrast and other opportunities, like magnification, image processing, whether it's filters or enhancements. You can obtain statistics, apply annotation, and all integrate this in the original scan. Yeah? The idea is that you can save a lot of time and money to go digital, but of course there are challenges in the workflow, and we have tried to address this 2 years ago. And so far we've been successful. What is a digital image? On the right you see the analog image, and on the left this is usually how a digital image looks like from a computer point of view. The computer transfers this over that the human eye can see an image like on the right, but that's the big difference between digital and analog imaging. Digital conversation. I'm sure most of you have seen this, the photography transition from 35mm to digital. And the medical and dental radiography is the same. I'm sure everyone still remembers the time, or still going. I mean, it depends on in what country you go and to what doctor. They still make analog images, and then they are being transferred into digital. Some countries are 100% digital. In Scandinavia, you have basically no more film in the medical side. In other countries, you're looking at anywhere between a 20-80 ratio to 90-10. But the conversation is all going to completely digital. And so we say that the NDT last to convert. Still primary form for radiographic imaging is the film. And it is just a matter of time, because the transition, what we went through, in my former career, I was in the medical for 12 years, and I transferred over 3 years ago to NDT. And it's basically the same, but of course specialized, different imaging, different quality criteria, complete different workflows. But it was relatively easy to transition this and be able to provide the quality which is required by the BAM and ASNT, but also of course for to get the approval of the inspectors. Very important, of course. The idea is to reduce the cost for consumables, for reshoots, for eliminating chemical disposals, charges, eliminate film storage costs, and improve image evaluation. Now, this is a phase, this is a transition. In medical it took 20 years, and in NDT we are looking right now, I would say, we started from 0 2.5 years ago, and we are probably now in 2 years out of 10 to 15. So this is a long term but a very clear beginning and an end in where probably the film will not go away but be limited to maybe 20% in 10 years, 8 years, 5, I don't know. So how is to explain that an entire industry converting 100% to digital as a part in Europe and North America? I'm simply right now referring to the medical market. The converting film in the medical market took 20 years. Like I said, many countries are now 100% digital, but not a minimum of 80% in the digital medical field. So The reason why this was working is because the industry, all the medical imaging providers, decided on a standard. And I'm not going to talk about medical standards today, but it is a standard on file formats, procedures, and workflow where all the manufacturers, whether this is a GE or whether this is Castry Medical, they are all following the same rules. And when a customer has a software package and a solution from manufacturer A, he can transfer the images to manufacturer B to be 100% compatible and have no problems for the end user. So this basically, it's a decision of what product to buy, but at the end you can transfer from one manufacturer to the other the image without any problems. I will come to this in a couple of minutes to tell you about this special file format. But this was the base and the most important factor that digital imaging got the boost once this file compatibility called DICOM was available, and there was no cross-manufacturer or cross-platform problem that, like I said, you have manufacturer A, you have expensive CRs and DRs, you do your scan, you want to send it over to a doctor thousands of miles away, they have a different system and they can read it. In the United States, the FDA has settled this, the National Health Organization, which is basically like a law. This is the file format, and if you want to sell into the medical imaging market in the US, and I think it's all over the world now, that you have to be compatible to this file format. So it was part of the workflow in medical, and I will transfer over to NDT in a moment. It was a focus in the beginning in the medical on CR-DR. It was the same situation that the big manufacturers focused on selling and promoting the CR-DRs, but the bridge over in medical back to the file vaults, to the analog X-rays, was, I wouldn't say forgotten, but it was something where we didn't care. So this started in 1995. As I mentioned before, and it took about 5 years to reach the point where all the large medical imaging providers offered a film digitizer as part of their system without questioning. This was like you buy a CR or a DR in the medical imaging field, and you get a scanner to do the conversation automatically if requested by the customer. And especially when you go into a medical exam, the priors are very important to do a diagnostic when you have a lung exams or something like this. And the application in the NDT field is basically the same. You're going to go in, have now a brand new CR or DR system, you have imaging, but you need to compare it to something. And then it's always good to fall back to being able to have a digitizing device that you can take the old analog images and put them into the computer, digitize it, and then can compare it side by side. This is the idea of this film digitizing solution, as I mentioned, like the bridge solution. So medical imaging, as I said, had a problem. How do we implement the analog X-rays to digital format? Exactly what we are talking about here in NDT. And like I said before, the incompatible prior film images compared to digital images. This was the challenge. So it was back in the medical times, about 1995, you had the light box film versus digital files. They had a light box, they had a monitor, and we're comparing the latest exams to the old, and it wasn't really helpful because you had two mediums, the analog way and the digital, so they had to convert. So it was from accessing the images to retrieving to digital imaging software, and this was done at the beginning without compatible file formats. So what I just mentioned where the medical industry was able to basically unify the file formats, at the beginning this was not the case. This only came like a couple of years after it was introduced as a technology. So the situation the medical facility demanded, and I always go back to medical because we see exactly the same happening in NDT. The film digitizers were included in the digital radiography proposals in order to be backwards compatible to bridge between analog and digital. The The result was that the film problem was solved. 40,000 medical grade film digitizers, it's basically something like this but customized to the medical, were installed worldwide, and there were only less than a handful of manufacturers available, and today it's actually only 2 left which provide this kind of solution worldwide because it's so specialized. And this is just to show you the file format which they used for to being compatible between hospitals and different manufacturers was called DICOM. And this DICOM format is actually, I would say, the father of now the file format for NDT, which is called DICONDE. And the criteria and the development was, which was developed for medical, was transferred to DICONDE. So basically the NDT standard file format is a, let's say, a child of the DICOM world 20 years ago. So the non-destructive inspection industry is our biggest customer right now, and this goes to that I was literally out as a construction site of a pipeline. Analog X-rays were shot and then put directly into a truck where a digitizer was, and the images were digitized. It's an interesting fact that the global industrial film sales, of course, still grow, and really dramatically compared to the sales of the digital systems. You would expect that, well, the films go away, which they did in medical. Currently, we are seeing a growth for at least the next 1 or 2 years until where the film sales are having their peak, and then you should see either a flat line or a light drop, and over the next 10 to 15 years where you see the digital conversation happening. So today, the converting from film to digital, it is in the NDT section pretty still a brand new solution where you can convert, like I mentioned before, from analog to digital. And our solution, what we created, is exactly to fix that problem. And our most important market right now is the inspection services. And we have literally customers who have service trucks with scanners inside. They go out on the field, like I said, do the analog images and then convert them to digital right on the construction site. The NDT field services workflow evaluating, comparing film to CR and DR, like I mentioned before. They have limited inspection times. It's the issue of light box versus digital. It's still nowadays in many countries completely incompatible because our solution is very new. And and you have with an analog and digital picture side by side, there is a visual quality and inconsistency. You have to double check, and you can compare on a monitor. And that's where I see the biggest benefit, that you have both images side by side digitally. Yeah, and of course, the staff has to be trained to handle the film and digital at this stage, if this technology is implemented. So, a complete solution for digitizing starts at around $35,000, and this is something where this is a turnkey solution: software, scanner, feeders, all what you need in order to be either mobile or work in the office. That is a complete solution. And we are seeing that with the increased sales of CR and DR, you are seeing increased sales of the film digitizer in order to be compatible from analog to digital. The film digitizing is an integral step to go completely from analog to digital. I hope I can predict that in 10 to 15 years, what is hard today, 100% film, might be 30% or maybe even less. Because these systems will get smaller, the CRs and DRs will get cheaper, like all the medical. When we started this, you could have a digital radiograph solution for $2 million, and nowadays you might get good systems for $250,000. So there, over the 20 years, there was an incredible price reduction, and of course the size of the digital equipment. It's cost effective. It also very important that when you digitize in this DICONDE format, you actually have all what we call the metadata as part of the image. It's not just the image. We have all the informations like when it was scanned, where it was scanned, who was the inspector. You can actually add reports to the image and have both side by side. When you look for an image, you have the reports right there. That's also a part of the technology. So you can get archived, organized, and retrieved. That means the idea is at the end that you have all what is today in analog, in boxes, in some vaults, which are expensive to maintain, that you have it digitally available, that you can share it either by DVD or by the internet very quickly around the world, like it is done today in medical. Now we are going back here to the NDT DICONDE file format compatibility. Many of our customers are actually not interested in NDT DICONDE yet because they work in JPEG or a TIFF, which of course is supported. But within the DICONDE we have the benefits I mentioned earlier. When you do, for example, JPEG files, you can lose up to 90% of your image quality. And it's not good anymore for qualifications for the level 3s, because you have lost so much quality that the images are not, at least in the United States, not more usable for quality purpose. Yeah. So we talked about the NDT DICONDE benefits, and more companies are. I think Carestream is also promoting the DICONDE format, and therefore all these systems are talking already hand to hand and are compatible regardless of manufacturer. Yeah, and like I said, just a nice image again. Our job is to convert from analog to digital. The system is supporting your investments already done on DRs and CRs, which you have, and is simply adding the opportunity to either go back from digital, if you're already there, to retrieve the analog images you have, or to start into the digital world while digitizing the analog images. In both ways it works and supports the transition to digital. So just my last chart is going back to DICONDE. As I mentioned before, it's based upon DICOM, which stands for Digital Imaging and Communications in Medicine. And it's the standard since 1993. That's even longer than what I mentioned before. And now we are going into the same from DICOM to DICONDE. It's digital imaging and communications for non-destructive evaluation. And this is the imaging standard, as I mentioned earlier, between the NDT world that assures the customer a compatibility with your acquired images. And in 2004, the American Society of the ASTM established the DICONDE as NDT imaging standards. And I'm just back from a test in Orlando, in Florida, about 3 weeks ago, where there was a compatibility test between 7 different manufacturers, where they sent images to each other to show that they're compatible to this DICONDE standards. And they all could change the images. There was no incompatibility depending on the manufacturer. So this has come a long way. Yeah, this is my short presentation about what we are offering and what is the idea. We expect that this kind of technology will become standard in order to provide the transition from analog to digital. Thank you very much for your attention.
Would anybody like to see the scanner actually working, digitizing existing film?
Yes.
Yes. Images?
So why don't we try to get this?
What I'll do is, I think, Michael, if you can just digitize there, and we'll bring